Okay, so we're recording here. Um, so, so my announcements here include I graded 1.8, although it's kind of challenging to grade on a computer, just to be honest. And so in some cases, I just wrote like, "Hey, it looks right, but you should double check your answers." So I also posted the solutions on Blackboard. Homework 1.9, the written homework, is due today as well. Please submit that on Blackboard. That will be the last written homework that we'll do. Everything else will be moving online after that. Um, and I looked into that thing that Oliver Todd had suggested. I mean, last time, the Cam Scanner app, and I actually used it on something the other day, and it works really nicely. So if you're thinking about using your phone to submit an image, please use this app. And I would recommend maybe just downloading that in general for all your classes. It's a really nice app. Thank you for bringing that up again, Todd. It takes a picture, but it reformats it so that it looks more like a scan. It'll brighten or um, decrease the brightness, whatever you call that, dim. It adjusts the colors basically to make it more visible. It's a really nice app. It puts a tiny watermark on it, I think, but it's very nice and manageable. I actually posted the thing from our class the other day with that. So actually, let me show you something. I'm going to share my screen here, and I want to show you what I've added to Blackboard. So I'm sharing my screen here. You should be looking at my Blackboard page. Again, I think when I share my screen, it creates two versions of myself. It creates like the version with my notes on it, where my hand is right now, and then it also creates a version with Blackboard. So I'm showing you Blackboard here. If you go into our Blackboard site, I've added a couple things. And so when you go to course documents, for one thing, under class notes, I added the help session we did the other day, and I used Cam Scanner to make this document. So this is the kind of thing that Cam Scanner will do for you. It just makes a very nice little image. You can see it puts this little watermark scanned with Cam Scanner on the bottom, but otherwise it like brightened it a little bit. It tried to trim out the edges, and it makes a pretty decent looking image. You should see some of the images I get on Blackboard. Really bad and hard to see. This is very nice and readable. So anyway, these are the notes from the other day, and anytime we'll take notes from these sessions, I will do a little Cam Scanner thing and put them up here. The other thing I did based on your suggestions, if you go back to course documents here, is I added all the quizzes we would have taken otherwise. So these are the quizzes we did take. Here are some of the other ones we may have taken if we stayed in class. And a couple different versions sometimes. And I don't always get to all these quizzes, just to be clear. It's not like we would have had all these quizzes. These are just some of the quizzes I've given the past times I've taught the course. So these are, especially the solutions would be nice to study from for tests and things like that. And these can help with homework problems too. Speaking of homework, if you go back to course documents, I posted all homework solutions that we would have done out of the book. So under written homework problems and solutions, here are all the problems that I would have assigned. And then down at the bottom, I've got all the solutions that you've turned in already, but then here are all the solutions for the ones in future chapters that we would have done. And again, these are really nice and helpful for homework problems, because when I was making the online homework, I tried to pick online homework problems that were similar to the problems in the homework, the written homework. So some of the problems in the written homework that the solutions are right here will help you with the online homework. Let me just remind you again, moving forward, online homework starting next Wednesday is going to be on WebWork, which you access right here in the WebWork tab. And you sign in and you log in using your Blackboard ID and password. And I've already got a bunch of the future ones posted. So I've got the ones assigned for next Wednesday. These two assignments you can see are due on 4/1. All the other ones I've just made due on May 13th, and I'll update them as I get, as we move into them and as they get set. I'm going to say something else about this. I was just going to check on your progress. Let's see how you guys are doing with it. Has anyone started it? A couple of people have started it. Oh, yeah. Nice. So anyway, that's due next Wednesday. Let me just remind you, too, that if you have questions on a homework problem on these, let's say you go into matrix operations and you have a question with number 1. Please click this email instructor button down at the bottom here to write me an email. What that does is it links me to your problem and it'll help me help you. You should also, if you haven't logged in already, just at least try to log in, because I entered all you guys by hand, And I may have messed up some spelling. I know I messed up at least one person's login information just because I misspelled his name or I added an extra letter or whatever it was. Anyway, that's all I think I wanted to say about Blackboard. I'm going to stop presenting my screen now. Are there any questions about things I've just said? Anything I've just shown you or anything I posted? Any questions about that stuff? Any questions about online homework? Like online forward, like how to access it or things like that? Just gonna pause for a minute and see if anyone's typing while I'm pausing and waiting. I was watching the videos before. I'd like to apologize for the quality, especially the video quality of the first couple, or the audio quality, I mean. I have some issues with my mic sometimes. I think I made the second couple, the next two, better, and I think I mentioned to him getting an external microphone. It would be at my house by next week. So certainly starting next week, the audio should be worked out in those videos. And over this interface. If I ever break up over this, let me know, but that should be fixed next week. Okay, Nick says, not sure if it's just me, but it hasn't left the announcement sheet the whole time. Okay, so Nick and anyone else, if that's the case, you probably pinned the image in the middle of the screen. So if you hover over the screen, there's a push pin, and you can click that or unclick it to force an image to stay in the middle or not. Did that fix it? Let me know if that fixed it. And let me just show you what I'm talking about. I'll share my screen again here. So this is my normal setup. I've got like a tile situation where I can see multiple people's screen. But if I want to pin someone's image up there, like I'll pin my own, I can click on one and then it stays in the middle. And see how this image, this pin right here is highlighted. So that's going to keep my announcement in the middle. If you want that to go away, you would click it again and it goes away. So I'm thinking that may be what happened to you, Nick. And if anyone else wants to see what I showed, okay, so maybe it's not the pin thing. I'm not sure. You may have it on Spotlight, possibly. Regardless, I'm happy to help you with that. And if you wanted to see what I did on Blackboard afterwards, you can just go and check the video I post. I'll post the video. So, I posted our last session to YouTube as well, if anyone wants to look at that again. Okay. I'm stop presenting here. I'm going to go back to the announcements. Are there other sort of housekeeping, technical type questions like that you want to talk about before we look at material? Okay, so the material was like about the powers of the matrix, and it was sort of wrapping up matrix multiplication section. And so powers of a matrix, kind of work generally the way numbers do. The key thing with those is you need to have square matrices is kind of the key thing up here. And then we have some properties down at the bottom that get applied sometimes, and we learned about what the transpose is. Were there questions about 2.1 at all? So I just want to sort of go section by section. So this is the end of section 2.1, and I was wondering if there are any questions about this or maybe anything in the homework that people have seen or looked at. Like it might be helpful after you watch a video to at least take a peek at the homework to see if the questions make sense, like you think you can do them based on the material you just learned in the video. And then that way, if one question, like you don't understand what it says or how to approach it, that's the kind of thing we can talk about right now. Okay, so there's a question about number 5 on the homework. Are you talking about section 2.1? Yes. Okay, wonderful. Let me pull up section 2.1. Okay, wonderful. So in section 2.1, let me get a piece of paper. So this is homework 2.1, number 5. And in the problem, you're given a, let me question one more time. I'll put it on my other screen here, actually. In the problem, you're given two matrices. You're given B equals 0, 0, minus 3, 1, 2, minus 3. Excuse me. And you're given a 3 by 3 for F. F is 2 minus 2 minus 1, 3 minus 1 minus 2, 0 minus 1 minus 2. This is the version that I have, at least, by the way. It may generate different versions for different people. So if you're looking at it right now and you're seeing two different matrices, you may have a different matrix. And maybe I should have just picked a different matrix so you could try it yourself. Maybe I'll think about that for future problems. Anyway, the question is, what is BF? So can it be performed? And what is the product if it can be performed? And so if you multiply BF, B is a 2 by 3. And F is a 3 by 3. And so in order to do that multiplication, we need the inside numbers to line up. And so these match. And so that means you can do the product. And so the first thing is BF is possible. So the answer to the first part, can it be performed, would be a yes. And then in order to actually perform the problem, what we learned about in this section was you create this kind of like tile setup where you put the second matrix here and the first matrix here. And so like B, I put right here, for example. And then F goes right here. And then your answer is going to be a 2 by 3 because this number is a 2 and this number is a 3. And so the answer right here is going to be a size 2 by 3, like the matrix that you end up writing in here. And the reason you do it in this tile setup is because, you know, if you want to have 3, you're going to have a 3 by or a 2 by 3. Oops, I should have drawn that line right down the middle. I'm sorry. You're going to have 2 rows and 3 columns. And so this entry lines up with this row, the first row from B, and the first column from F. And so you dot those 2 columns. You do 2 times 0, 3 times 0, 0 times 3. And so that's adding up a bunch of zeros. And so you put a 0 in that spot, for example. Right? Like this spot right here lines up with the bottom row and the right-hand column. And so you'd multiply the right-hand column with the bottom row. And so it'd be minus 1. 2 times minus 2 would be minus 4. And then minus 3 times minus 2 would be a plus 6. So when you do minus 1 minus 4 plus 6, that's a minus 5 plus 6, you get 1. And so that's how you end up filling in all the entries to get a 2 by 3 matrix. Now, I don't know if that was a question about how to do it, or maybe you were trying to do it and you're getting the wrong answer. And so that's certainly an issue too. And let me just go ahead and get it out there. One of the worst parts about online homework is sometimes trying to figure out how to enter an answer. And so if that's a problem, we can certainly talk about those issues as well. But that's kind of the general approach there. Does that clarify things for you, Sydney, or did you have some other question? Do you want me to keep going with this one? Or anyone else who has a question about it or wants to comment on it? You're welcome to use the chat if you want. You're also welcome to talk. I don't want to, whatever works for you.
Yeah, I was just confused with like how to line them up because I was multiplying the wrong rows by the wrong columns.
Okay, that's why this this like whatever chart type setup is so nice. And actually, I didn't do this when I learned this. This is not how I learned it. And I was taught this recently, like 2 years ago, by another professor in the math department. They saw how I was teaching, and they were like, "Oh, well, there's this really nice way to do it where you can line up the rows and the columns." And so I immediately latched onto this because of exactly what you're saying. If you know how big your answer is going to be, you know where the different spaces are, and then you just like point to a space, and then you line up the column and the row that you're going to multiply the two things together, right? Like this space right here is going to be this column and this row, for example. Does that make sense? You think you can do that now?
Just throwing this out there, I think that makes a lot of sense and explains it really well.
Wow, thank you, man. I really appreciate that. No, thank you. That's helpful. Any feedback is helpful. I don't know if anyone can hear me, honestly, if I just sit here and say things. So anyway, I appreciate that. Other questions about this one or other ones? What else is on your mind related to 2.1? This is exactly the kind of thing that we want to be doing, right? So obviously Sydney watched the video. She was looking at the homework, was sort of tripped up by
Can you
one.
go over the rules as to what properties allow us to do what with matrices? As in, like, you know, obviously they have to have the inner dimensions equal to multiply them. I think they need to be of the same size, of the same column length and row length in order to add or subtract them.
Yeah, we can go over the different things here. So in general, let's say A is M by N, and let's say B is two other letters, P by Q. If we want to add or subtract, you know, A plus or minus B, all dimensions have to match. So M has to be the same as P, and N has to be the same as Q. Right, because when you add two matrices, you're just adding where the entries correspond, and you need to have them correspond to something, right? So that's sort of the idea there. To multiply matrices, you need to have the inner dimensions match. So this would be M by N, this would be P times Q, and so you need N to equal P. And what happens is A times B ends up being M by Q. Right, so the inner dimensions need to match in order to make it happen. And then the result ends up being the outer dimensions. So these two things give you this. There's no such thing as matrix division. You can multiply by the inverse, but which is sort of kind of like matrix division, but it's not the same. Right, because first of all, A minus 1 might not exist. You need a square matrix. Even if you have a square matrix, it may not have an inverse. And so that's like the matrix version of division, but it's not the same as division because you can always divide a number, right? But what I'm saying here is you can't always divide or multiply by the inverse. Partially because it's not always true, and it's usually not true, that A times B equals B times A. Right, so that's like, this is going to be confusing. Let me cross this out. Let me write it like this. A times B does not equal B times A in general. And what I talked about in the video to begin with is if you wanted to do that in the first place, they need to both be square matrices that are the same size. And so heck, most square matrices or most matrices are not square nor the same size. And so most of the time you can't even change the order to begin with. And even if you can change the order, they're not going to be equal most of the time. Is that the kind of thing you were looking for, Fenton?
Yeah, just a general overview of this sort of information. Also, what was the formula again for finding the inverse if it's just 2 by 2?
Sure, yeah. So the inverse of a 2 by 2 is what's on the bottom of page 6. So the bottom of the first page of 2.2. So if you've got a 2 by 2, you just switch the order of the first and the last entry. So instead of A and D, it becomes D and A. And then you leave C and B in the same spot, but you just switch the sign. So if they were negative, they become positive, and if they were positive, they become negative. And then you divide every entry by the determinant, which is what's in chapter 3, which is AD minus BC. And so you do 1 over AD minus BC, which ends up, in this example, ends up being minus 1/3. You switch the entries, switch the signs, and then you just, what this ends up doing is it just ends up dividing everything by -3. So that's how we get to the same answer. Now let me just sort of continue with that. Did I say AB minus DC? Yeah, AD minus BC. I'll answer Ryan's question in just a second. Let me just sort of continue with that. This is how you do it with a 2x2. If you want to do it with something bigger than a 2x2, that's where you use the algorithm on page 8. And so theorem 7 says, hey, if a matrix is invertible, it reduces to the identity matrix, and moreover, the operations that change A into the identity change the identity into the inverse. It's a really interesting thing. And so what you do to find something bigger than a 2x2 is you put the matrix in a larger matrix with the identity matrix, and then you do RREF, and RREF kind of ignores the right-hand half of this, right? Like it just focuses on here. It tries to put a pivot here, here, and here. And so it like messes around with this left-hand half of the matrix, but it applies the same operations over on the right. And so it basically applies theorem 7 is what I'm saying. And so that'll change A into the identity, and it'll change the identity into the inverse. It's just really cool kind of theorem. And then the idea is if it doesn't change into the identity, it's not invertible. So question about theorem 4. Someone says, is theorem 4 something we need to memorize? You should know how to do this. Yes, you should memorize. I'm trying to think here. Think about that. Technically, you could just, if you had a 2x2, you could just use what I just said a second ago. You could use this property with a 2x2, technically. So the question is, will I ask you specifically to use the 2x2 inverse formula? That's something you should know. I think I might, yes. Like this is something that like anyone who takes linear algebra should kind of know, in my opinion. So yes, I think you should memorize it, and I may ask you specifically to use that. In the homework, I'm pretty sure you need to use that specifically, so keep that in mind. Okay, so we've kind of moved into 2.2 here. Were there other questions about 2.1 at all? Things that in section 2.1 that people want to look at? If not, I'm happy to keep talking about 2.2 if there are other questions about either the material in 2.2, like the notes, or web work 2.2. I don't know if anyone's looked at that yet. Let me see if anyone... Looks like one person started it, but no one else has. So, but again, maybe you looked at some of the answers. Like I think it's a good idea to, I think it's a good idea after we do a section in the video to at least like thumb through the homework questions to see if they look manageable. Right? That's because that's going to be most helpful for you in this situation. I'm happy, the next time we meet, we can look at homework in 2.2 as well, but that's going to be 5 days from now. And, how much do you remember by then, all that kind of stuff. If you just kind of watch the video and then at least page through the homework, ideally you could work on some before our meetings, that'd be good. But anyway, I'm still happy I can reiterate something that you didn't understand in the video, or answer another homework question, anything that you want to talk about. I should remind you again that you should submit homework 1.9 by tonight. I saw a couple people had done that. I graded whoever submitted it yesterday. Let me see if anyone else has done it overnight. Yeah, so most people have not yet submitted 1.9. I see someone submitted 1.8 late. I will accept that given our circumstances, but kind of moving forward, you'll start to hopefully get in the habit of homework just being due Wednesday nights, 1 or 2 assignments, depending on what's going on. And I'm hoping not to extend those very much. I'm happy to in general. Like here I am saying, oh, I won't extend it, but then I'm also saying I will. But please try to do it on time. If you need some more time, let me know. Any other questions? I'd love to answer a question. Okay, well, if not, I'm gonna post this video to YouTube. If you want to talk later, I'm sitting at my desk most of the day just working. So like we can pop back on here. I can help you with the homework problem. Let me know how I can help you. That's it.